So here's the answer, okay? Remember, for this to exist, let's say L, okay? Then that means that y over x has to approach this L as xy approaches 0, 0 from every direction. So a strategy which we will be using over and over again for the next half an hour, maybe an hour, and in your homework a lot repeatedly, is to come up with two directions, or maybe more directions. Two is enough. Two directions to in which to approach this particular point, so that they will give you different limit values. Okay, if you can find two paths so that the value of the function approaches two different numbers, then that would forever prove that the limit does not exist, because the definition of the limit requires that no matter how you approach that point, then the f of xy must approach that number L. All right, so think about a couple of maybe three standard ways of approaching this, okay? So the way to approach this origin 0, 0, okay, of course you have a bunch of ways to do this, but the standard ways to approach this is this way, and along the path x is equal to y is equal to x. Right. I'm going to give you this as number one. This is where x is approaching 0. Notice here, the arrow is indicating x is approaching 0 from the positive side. Y is constantly 0. You get that? Right. And number two, x is approaching, well, x is actually 0 along here, and y is approaching 0 from the positive side. Over here, path number 3 is where x and y stay equal to each other, and they are both approaching 0 from the positive side. Think about what happens to this expression y over x. Okay, so number one is this path. What is this path for number one? Y is equal to 0, right? And then x is approaching 0 from the positive side. On this path, f of xy, which in this case is y over x, is guess what? Remember, as x approaches 0 from the positive side, we are saying that x gets closer and closer to 0, but never is equal to 0. So all these x values are non-zero numbers. Y is definitely 0. So this is 0 over x, 0 over 0.1, 0 over 0.001. 0 over 0.0001 as x gets smaller and smaller. But guess what? For every x value that's not equal to 0, which is our assumption, 0 over that number is always 0. Okay, so this is constantly 0. You know what I'm talking about? As you approach this point along 0, 0 from the number one direction, as you walk on this path here, okay, the value of the function is constantly 0. Okay, so it is approaching 0 because it's always 0. Now, number two is this vertical approach where x is equal to 0, y approaches 0, but never is equal to 0. Over on this, what's going on here? Well, x is 0, so this is y over 0. This is undefined. In fact, this is a bad word that I just wrote. I should be embarrassed. So maybe I should not let you see this anymore. It's undefined because of the 0 in the denominator, right? And in fact, this approach 2 is not even in the domain of this function because x is equal to 0. Now, what happens when x and y are equal to each other, as in path number 3? Okay, in this situation, f of xy is y over x. Remember, they're the same, y over y, and that's 1. Okay, so here's the picture. As you approach 0, 0 on path number 1, the value of the function stays 0. As you approach 0, 0 from in this direction on path number 3, it continues to stay as 1. So the limit on path 1 is 0. The limit on path 3 is 1. You notice that these are not equal to each other, okay? That is a proof that the limit does not exist. D and E, you seen that, does not exist. So the answer is the limit does not exist. Again, undefined is not the correct answer. 0 over 0 is not the correct answer. The limit does not exist is the correct answer, and here is a correct proof. You may be able to find other paths on which the limit is different from 0 or 1, but as long as you see two paths so that the limits are different, then you have shown that the limit does not exist. All right. With that in mind, you have lots of questions. Now, in section 1, you had over 30 questions. In section 2, you have less than half or fewer than half of those questions, but they're not necessarily easy. They're not necessarily hard, but you will have to be clever and come up with some creative ways to find limits. I will show you a few of these things right now. First of all, let's recall that, you know what happens with sine of x over x as x approaches 0. Okay, they both go to 0, right? And if you remember, the sine of an angle is really just the y coordinate of this point on the unit circle. And the x, in radian mode, this really is the arc length of this angle, which we call x right now, and they are approaching 0 at the same ratio or the same rate, really. So this is, as you proved in calculus 1, the answer is equal to 1. Okay, so with that, let's try to find out what the limit is for this one. Y sine of x over 2xy as xy approaches 0, 0. Okay, can you find this? Obviously, you cannot plug in 0 and 0 because you'll have 0 over 0. And please don't say undefined. That's not the answer. Please don't say 0 over 0 because that's a terrible answer and just a terrible thing to talk about. So what you can do, and the other thing is you can't do this, okay? Because these are, the top is not just x, it's a sign, you leave sin behind when you do that. And so don't leave sin exposed. All right, so what do you have to do here? So what you can do is you can continue to write this cumbersome thing here, but you have 2, and you have y and y, they can cancel, okay? Because remember, y is never 0, y is approaching 0, so y over y is still 1. And then you have x over sine of x. That's the only thing that's left, okay? You can even write it this way. The limit of a product is a product of the limit. So this is 1/2 times the limit of sine x over x, which is 1, and the answer is 1/2. Not bad, right? Okay. How about this one? Find the limit as xy goes to 0, 0, as they often do in these problems. How about this one? Can you find this? And I'm going to ask you a series of questions, and at this point, maybe you can pause and try to figure this out. Let's say f of x is 2x squared y over x to the 4th plus y squared. And of course, I want you to find the limit of this as xy goes to or approaches 0, 0. Okay, and then I'll have a few more examples. Okay, let's focus on these. And then I'll have a couple more questions. What I'm trying to do is to get you prepared for some of the challenging homework problems, okay? Because some questions do require you to come up with some, innovative thinking, which is really what mathematics is great for, right? Trying to find a creative way to solve problems given the restrictions and, the rules you have to follow. Okay, so for this one here, well, you try to plug in numbers, 0, 0. Of course, it doesn't work. Okay, and notice here, the top is, y and x are subtracted, and bottom is y and x are equal to each other. So I would ask you to try, again, all 3 of these paths, 1 here, 2 here, 3. And sometimes you may have to do something else here besides this. And what path can you consider? Well, that's a pretty difficult thing to answer in general, right? But if you think of this as f of xy, let's think about this. F of xy. Oh yeah, so 1. So 1 is the path where y is equal to 0. 2 is the path where x is equal to 0. 3 is the path where x is equal to y, right? So if you, you know, I have too many ones and twos. These are parentheses here. Along path 1, f of xy is, remember, y is equal to 0, right? So this will be x minus 0. What am I hiding this? X minus 0, x plus 0, which is 1. Okay, so along this path 1, f of xy is always 1. Okay, in fact, it is approaching 1, but it is always 1 for any x value that is not equal to 0. Along the path number 2, that's this one here, right? In this case, y is non-zero, but x is. So then you have 0 minus y over 0 plus y. You can clearly see this is equal to 1, right? And this approaches negative 1. And so there it is, okay? You have found that the limit does not exist. And that's because you have found two paths, so that along one path, the limit is 1, and then along the other path, the limit is negative 1. Okay, number 2. Oh, by the way, if you, just for the fun of it, do number 3, where x is equal to y, then you have on the top x over x minus x, because remember y is equal to x, and then x plus x. That's 0 over 2x, and that's 0. So this is yet another third value, which is different from the first two values. So you could say the limit does not exist. Obviously, you don't need to have all three of these, you know, but two of these, any two of these will suffice. Okay, number 2, this time find the limit of this expression. And let's try again, you know, with our 3 standard ways, 1, 2, and then 3 where y is equal to x. 1 is where y is equal to 0. Remember, by the way, anytime you come up with these paths, make sure they are approaching this point, okay? Because if these paths are not approaching this point, there's no use, okay? It's meaningless. So here, x is equal to 0, but y is not, right? Okay, so if you do number 1, f of xy, remember, according to 1, y is equal to 0. So this is the expression, and that's 0, okay? Remember, x is not 0, so this is constantly 0, approaching 0. Number 2, if you approach the origin along the path number 2, then x is 0, so this will be 2, 0 square y over 0 to the 4th plus y square, and that's 0. And so that doesn't give us any different value. Number 3, if y is equal to x, I can just rewrite y as x. So this is 2x squared times x, right? And then on the denominator, you have x to the 4th plus x squared, because y is simply the same thing as x. That's interesting. What is that? Okay, so this is, well, that's 2x cubed over x to the 4th plus x squared. What is that? Well, I can take out maybe x squared from both. And so you have x squared plus 1. Is that okay? And then you can, because x is non-zero, remember x approaches 0, but x is never 0. So this and this you can cancel, not quite. The top is going to be 2x. The denominator is x squared plus 1. If you plug in x is equal to 0, or x approaches 0 here, actually x can be plugged in as equal to 0. This is 0 over 1, and it is 0. Again, 0, 0, 0. Maybe the answer is 0, right? And so this is a really hard question. Well, it's not real, but for right now, for most of you, this is a hard question because the answer, the evidence has been inconclusive so far. In every path that I tried, which is all three of them, the answer turns out to be 0. So maybe the answer is 0, but I haven't proved it because I haven't tried all directions. In fact, you will never be able to prove those are equal in all directions because there are infinitely many directions. So what is that? We'll continue to find something, okay? How do you do that? Well, maybe try something else. When you see this is x squared, you have x to the fourth. If this is x squared, you'll have x to the fourth on the top and x to the bottom, x to the fourth on the bottom. So looking at this carefully, once again, you may want to try, how about y is equal to x squared? Okay, this is where your discretion and maybe innovative or observation or keen observation or innovative strategy comes in place, right? So we will try this path. Let's say now I want to create path number 4, which comes to the origin along the parabola y is equal to x squared. Now again, x is approaching 0, so y is approaching 0, but neither of them is exactly equal to 0. So along this path, f of xy is 2x squared, and remember y is now x squared along this path, and then the denominator is x to the fourth plus y squared. That would be x squared squared. Ooh, I think we're getting something. This is 2 to the x to the fourth divided by 2 to the x, 2 times x to the fourth. That's exactly 1. Yay, right? So do you see what happened? If you follow path 1 or path 2 or path 3, okay, then your value will always be equal to 0, okay? In fact, it's constantly 0 along this way, this way, this way. And so you may be tempted to think that the limit is equal to 0 until you try to find another path. And so here's my path, the yellow path, the yellow brick path. If you follow the yellow brick path, then something else happens, right? What happens along that yellow path? Y is equal to x squared. Along that path, it's constantly 1. Okay, so it'll be like coming in this way, right? And so in that case here, we have found that the limit still does not exist. But it was hard to prove it, okay? And nobody is going to tell you, hey, there is a path, you know, go along with it. You have to find that path on your own. Sounds like some sort of a meditation thinking. You must find your own path. Okay, so with that, I'm going to give you maybe a couple of... I'll stop the recording right now. In a second, or in the next part, I will give you a couple of other extra questions.